Polar creatures that depend on ice for all or parts of their life cycle are highly threatened by a warming world. The Arctic is home to at least 6 varieties of seals, sometimes called ice seals because they spend most of their time on or near the ice. The melting ice of the Arctic ice caps has endangered the habitat of some species, especially those that live near the outer reaches of the ice. Efforts to save these beautiful animals are underway, and public awareness is key in that struggle. Hello, my name is Seely, and I'm a harp seal. My herd and I are opportunistic feeders that swim the cold Arctic waters in search of fish and crustaceans. We can stay submerged underwater for up to 15 minutes in search of benthic organisms. Our grayish-colored bodies are marked with a darker saddle across our backs. We can grow as long as 6 feet and may weigh up to 600 pounds. Hundreds of thousands of us are harvested each year in seal hunts, and we are the favorite prey of polar bears. Environmentalists and animal rights activists are especially concerned about our future because the fluffy white fur of our young is prized by trappers and hunters. Arctic sea ice helps regulate climate globally by reflecting sunlight back into space, which is referred to as the albedo feedback. When the planet's albedo, or reflectivity, increases, more incoming sunlight is reflected back into space. This has a cooling effect on global temperatures. Conversely, a drop in albedo warms the planet. Snow and ice are highly reflective, so when they melt, albedo drops. This warming effect is seen in the Arctic. As the atmosphere warms, sea ice and snow cover melt. A surprising amount of carbon is trapped in Arctic tundra. Melting ice is responsible for increased emissions of methane, which is a potent greenhouse gas. Massive amounts of methane gas are currently trapped in and beneath permafrost in the Arctic. If climate change allows these gases to reach the atmosphere, they will cause even greater warming. This kind of positive feedback is very difficult to reverse and will affect the mortality of many marine species. Sea ice is a big deal for us harp seals. Since we are born unable to swim, we are given birth on ice packs that are attached to the ocean shore so that we don't drift away in Arctic strong winds and drown. Snow cover is also important for us to use to build layers to give birth. The graph presented shows the declining volume of Arctic sea ice from 1979 to modern day. Based on this data, one can conclude that the decrease in ice volume will have detrimental effect on the harp seal's habitat. Massive amounts of harp seal pups have been drowning. Past data indicates that in 2007, less than 25% of pups in Canada survived due to poor ice conditions. However, in 2010, fewer survived. Studies have shown that there's a positive correlation between decreasing sea ice and the increasing number of death rates among harp seals. My herd is having a hard time dealing with the changing climate. The warming climate is accelerating the start of the spring ice melt, which reduces the area covered by ice during February and March. My friends at Duke and the International Fund for Animal Welfare found that in years when a natural climate cycle called the North Atlantic Oscillation was in its negative phase during February and March, the sea ice cover was lighter and the death rate for our pups was higher. In years when the North Atlantic Oscillation was positive, ice cover was heavier and the death rate for our pups was lower. Scientists believe the North Atlantic Oscillation is a strong influence on annual variability in sea ice cover and seal death. The negative North Atlantic Oscillation Index phase shows a weak subtropical high and a weak Icelandic low pressure zone. Due to reduced pressure gradient, there are fewer and weaker winter storms. Hence, Greenland and Canada have milder winters. These conditions are reducing the habitat of harp seals. In contrast, the positive North Atlantic Oscillation Index shows a stronger Icelandic low pressure gradient, meaning there are stronger winter storms and colder winters in northern Canada and Greenland. These are ideal conditions for the harp seal species. My colony is searching for more favorable breeding grounds because conditions in our usual habitat are not ideal. Another reason is that sea ice is melting faster and earlier in the season than we expect, depriving us of the environmental cues that guide our northward migration. That is why we have been spotted far south of our traditional spring breaking grounds in Newfoundland and the Gulf of St. Lawrence. Global warming has greatly affected the food sources of harp seals. Trophic mismatch is a predicted consequence of climate change, in which the availability of food shifts in response to warming. The change in the blooming cycle of marine plants may lead to insufficient food for Arctic cods, which are the primary food source for harp seals. As the food for harp seals decreases, their feces also decrease. This affects the trophic web as it decreases resources for planktons. Ultimately, this leads to a chain reaction within the food web. Rising mercury levels, attributed to fossil fuel combustion and therefore global warming, can also harm the harp seal's fitness. Researchers believe fish the seals eat in the winter contribute to the annual fluctuation of mercury levels. Since harp seals' diet primarily consists of fish and benthic organisms, an increase in mercury ingestion in these organisms would result in a higher concentration in seals due to bioaccumulation. High levels of mercury can prove poisonous to these mammals. Poor conditions of ice and snow coverage has drowned thousands of harp seals. Immediate action should be taken to prevent further destruction of harp seals' habitat. Scientists believe that the study of harp seals and their changing habitat offers an opportunity for biologists to study the relationship between the animals and the ice and act to keep seal populations healthy as climate changes.